So our first PowerPoint is going to be a rather short one, just to introduce you a little bit to what kinesiology is and what we are going to talk about in this class. So kinesiology, by definition, is the science of movement. So we have to think about what that entails. So the first thing that it includes is the study of the structure of the bones and muscles. So we're going to be learning all about the skeleton, all about the muscular system, potential actions, right? What can the body do? How can it move? Important to remember that bones cannot move on their own. If we had just a skeleton, no movement would take place. We depend upon the action of the muscles on the bones for movement to occur. So, what actions can these muscles perform? And as we learn about the body, you're also going to learn that the way the body is structured, there are limits to ways the body can move. And one that you can think of is your knee, right? You can bend your knee forward, but you never want to bend your knee backwards. And your body is set up to restrict that kind of movement. So the bones and muscles are built in such a way to allow for certain movements to prevent others. And then the alignment of your body, the ideal position for your body to be in. How is your body meant to be aligned? How are the bones meant to rest upon each other? And this is really, really important because our body works best and most efficiently when it's in the position it's meant to be in. And we tend to let it be shaped by our actions. So, for example, if instead of carrying your backpack looped over both shoulders, you just hook it over your right shoulder all the time, without you realizing it, you're changing your alignment. You're changing how the bones are lined up in your body because your right shoulder will tend to drop a little bit lower. And in doing that, your spine curves a little bit more. And by your spine curving to the right, you constrict the rib cage on the right side, which makes it a little bit more difficult for you to breathe because the rib cage, of course, is over your lungs. So it makes it a little bit harder and takes a little bit more effort for your body to fill that right lung with air. So a simple thing like continually carrying your backpack only on your right side begins to change the alignment of the body and make the body less efficient. So those are the things we're going to be talking about when we learn about the bones and the muscles. Then we're going to be talking about something called biomechanical analysis. And that just means looking at how motion occurs. And for motion to occur in one group of muscles, another group of muscles has to let that action occur. And that's a whole concept we're going to be looking at because all muscle groups operate in pairs. So for instance, if we talk about your arm, right? And if I want to bring my arm in, the muscles on top of my forearm, my biceps, have to actually perform the action. So they're actually doing the work. If you were to do this and put your hand here, you would feel that muscle tighten. But in order for that muscle group to work, the muscle group underneath your forearm, which are your triceps, have to allow that movement to occur, right? They have to lengthen a little bit so that this can shorten and pull your elbow toward you. And then the opposite is also true. As this muscle pulls, because this muscle connects here, so as it pulls for your arm to extend again, this muscle has to relax and allow that movement to occur. So that's something we're going to study and be very much aware of. The third thing we're going to be looking at is neuromuscular analysis. And that's a fancy word for saying how your nervous system and your muscular system work together. We depend upon the nervous system to get input from our environment, So the nerves carry that input to the brain decides what's going to happen and sends signals back out to the muscles. And our neuromuscular system wants to operate in the simplest way possible because that uses the least amount of energy and is most efficient. So we're going to talk about things like when you're walking, right? Thinking about how your feet are facing. Are your toes facing forward versus going out at an angle and are maybe less efficient? What is the quickest, most efficient way to perform an action using the least amount of energy? So all three of these, right? The structure of bones and muscles, studying how movement occurs and is allowed to occur, and how efficiently movement should occur is the science of movement, or kinesiology. And that's what we're going to be looking at in this class. It's important for you to remember that everything we're going to be learning about in this class is based in science. And everything in science is arrived at in the same way through something called the scientific method. So nobody's guessing at how the body is put together and how the muscles work. Everything we're going to be talking about has been studied. So how does all this occur? Well, somebody comes up with a question, and then they begin to do a little bit of background research. So I'm going to give you a very simple example. I'm going to say that there's somebody who believed that the spine was made up of 4 different bones, right? There was one bone for the neck region, one bone for the region around the ribs, one bone for your middle back, and then a 4th bone for your lower back. They've done some research on studies that have been done on movement and have decided the spine is not one solid bone. It's made up of 4 individual bones. So they create a hypothesis, which is a theory. And their theory is the spine has 4 different bones. And then they're going to gather a bunch of people together. You never just study one person, right? Because that one person you pick could be the anomaly. It could be the person whose body was shaped differently than everybody else's. So they're going to take a large sampling of people and they're going to do some tests. And the tests they're going to do are movement tests and probably an X-ray. And do those tests show what they want them to show? Is the procedure working? Yes. If it wasn't working, they would go back and design a different test. And then they're going to look at all the data they come up with and draw a conclusion and decide, did they prove their theory or did they disprove their theory? And what they're going to find is their theory is not correct. The spine is indeed made up of more than one bone, but it's not just 4 bones, it's many more. So then those results get communicated, and they get communicated through scientific journals. So they would write up their findings, they submit it to a journal, and these journals are peer reviewed, which means other scientists are then going to look at the article, look at the whole experiment, make sure it was done well, make sure there are no flaws in how the experiment was done that could have led to a wrong conclusion. And then if they agree that everything was done correctly, then this study will get published and dispersed out to the public. And then, you hear things on the news like a new study was done proving such and such, right? We're hearing that a lot with everything going on with the pandemic right now. There are studies being done on wearing masks during exercise, on how efficient the vaccine is going to be and how effective the vaccine is going to be. So, conversely, using our example of the spine, there was another person who did research who thought, oh, I think the spine is actually made up of multiple bones, maybe even 33. So they create this theory. They would go through the whole testing procedure, gathering many subjects, doing tests, analyzing the data, and coming to the conclusion that their theory is actually correct. Write it up, send it to a journal, gets reviewed. Scientists say, yes, they went through the proper procedures, everything looks like it makes sense, and then it gets distributed to the public. So know that everything we are studying in this course was arrived at through science. And you're going to hear when we start talking about muscles that they thought this muscle just did this, and now they're studying it a little bit more because they think it also does something else. So research is constantly being done, and it is done always through this scientific method. And you're going to get to read a journal article in the next couple of weeks and actually look at who the subjects are, what the hypothesis or theory was, identify the conclusion, and look at the tests that were done, just so you get an idea of how this information is dispersed to the general public. Okay, so now we are going to dive a little bit forward into looking at movement. A lot of what you're going to get in this week's module is terminology and vocabulary that we're going to be using the rest of the semester. This class is cumulative. Everything builds, right? So nothing I'm giving you this week is just introductory stuff. It's all terminology and vocabulary you're going to need as I move forward with the lectures, because I'm going to be using this terminology. So it's important that you become very familiar with it. By the end of the course, you're going to be surprised to look back and realize, oh yeah, I didn't know what that word meant at the beginning of these 14 weeks. So there are 3 planes in which movement occurs that we're going to be talking about. The first is the sagittal plane, and your coloring this week is going to help illustrate that. The reading will also help supplement this. The sagittal plane runs parallel to the side of the body. So it's as if your body was standing against a wall on the side. And any movement you would do while standing against that wall would be considered in the sagittal plane. So I am going to stop sharing my screen right now so you can get a look at me performing some movement in the sagittal plane. So I'm standing against the wall. The wall is my sagittal plane, right? That's the plane of movement. So the movement I'm doing is as if I have an axis that I have to move on that goes through the middle of my body. So it's as if I have an imaginary pole, right, that comes in through the front of my body, the anterior, and goes out the back, the posterior. And all my